Hey all, can you confirm that you are able to see my laptop screen and I'm audible and clear? You can just text in the chat window so that I can check it. Thank you very much. Fine. Okay. So just let me put it in the presentation mode, right? So what is the objective of our course? In a simple terms that we are focusing on Power BI, which is a business intelligence tool, or we can say data analytics, right? And PostgreSQL. These are the two topics or two courses that we are covering as a part of our course. And we are going to aim the certification Microsoft Power BI Data Analytics PL300 certification, right? Now let us come to the thing what we are going to learn. So as a part of our 3 weeks course, right, we are going to cover data warehousing, PostgreSQL and Power BI. Now why all this course? Why can't it be simply directly we can go with the Power BI, right? So for this one, I will just take a simple flow diagram or a simple diagram that shows how the data flows in the real world, right? Now if you see here, data to insights journey, right? In the current world, business world or current world, everything is being digitalized. That means lots of data is being generated in the business world. Say if you take any retail, if you take any banking, right? Or if you take any small grocery shop also, where they use it to maintain their ledgers, their transactions on a pen and paper, on a book, right? Now everything is moved to the online, right? Through the laptops, tabs, or mobile apps nowadays for each and every business, right? When it is small business, that organizations are providing some app where they can quickly capture all the details and put their promotionals, everything. Correct? So over a period of time, data has become an indispensable in the business world, right? In earlier times or in the early stage or in early 2000s, data is like that, okay, it's an additional asset that we need to carry, right? Okay, we capture all our transactions on the books. At the same time, we need to keep them in the laptops also, just a kind of storing that one. But over a period of time, business has realized that, okay, why to leave that data as it is? Why can't we pull some data insights? Right? Well, let us analyze the data, understand it, right? And see what is the business patterns, what is where there is an opportunity for business. All those things are coming, right? So all these things we are terming it as a data factory. Now within the data factory, we can have the data that is generated through the devices, a mobile app, right? Or a sensors, ATM machines, all those things. If you take it's a banking. At the same time, there would be associates, those are sitting in the bank manually, they would be entering lot of data to the customers related to the customers, right? And any new products that we take, all those things. Now, this data is stored in database or anything streaming platform or HDFS system. So in a nutshell, we are calling it as a data factory. Okay, this is a logical terminology. There is nothing a separate factory is there. Suppose if you have a retail business like Walmart, now what are the activities those are captured from the front end? Those are all considered as a data factory. Now this data is further fine-tuned, converted into the analytics form, right? And on top of it, we are going to use Power BI to generate a meaningful insights. Now, why Power BI? Not others means yes, these are the market leaders. We have Power BI, Tableau, and couple of other reporting tools also there, right? But out of this, the honestly saying that the Power BI and Tableau are the market leaders. Okay. Now Tableau is a altogether complete different tool. But the good thing with Power BI is, let me open it. It's a Microsoft developed tool. Now, what is the advantage it further gives with respect to the when compared with the Tableau is the user interface, the UI, all those things almost similarly looks like you are working on a Microsoft Office tools, right? If you see, if I take one of the previous report, let me take it in the recent, and also let me open, and anyway I have. So if you see here, if you take this presentation, right, we have the options are related to the activities that we can do, right? Copy, paste, layout, or alignment, some kind of options, and insert different. So all these are grouped, illustrations are grouped, links are grouped. Similarly, when you see the Power BI UI, right? If you see this is the report view page, which looks like our PowerPoint presentation, right? And when you go to the insert, you can see the AI visuals, normal visuals, like Power Platforms and shapes, all those things. The first thing is we all have the opportunity to work on Microsoft Office, Excel, PowerPoint, these kind of tools, right? And our Power BI also more or less close to that one. If you go to the tabular view, right, this looks like a Excel. See, so this is one of the advantageous thing with the Microsoft Power BI. Okay, and as a part of our Microsoft Power BI, we are also going to learn artificial intelligence visuals, AI visuals, right? Now I'm just coming back to this presentation. Now, in this journey, where we are going to sit, because at many times people would be asking, hey, we need to learn a lot of things. There are a lot of tools are in the market, and every time when you do a Google or when you ask a friend, he may say that this is what currently going on, right? Now, in this entire journey is divided into four parts, right? Operational data, data ingestion and ETL, analytical data storage and processing, which means data warehousing kind of thing. All this central part comes into the data warehousing. And finally, there is a data modeling and visualization, right? If you heard the word that one image tells thousand words, right? In that way, whatever the data we are having, right? If we directly take a table of data to our management and say, hey, this is what my sales, then it's really not going to help, right? A simple example, suppose this is the data of the sales data is there. Now, if I take this table as it is to the my senior management, hey, this is what the sales, really it is not going to give them the right level of information. But if we present that in a nice image like this, a bar chart, a column chart, then they can understand which team is contributing, right? How much, or which country is contributing how much, right? So we Power BI data analyst mainly focusing on the data modeling and visualization. Okay, if you ask me, hey, what we are going to do is we are going to do data modeling and visualization. Okay, that is what our aim and objective. For that, we are going to use Microsoft Power BI, right? Now, the good thing and the advantages with the data analytics is, right, our end users are like business users, company management, right? Or something like a CEO, CFO. So, which means that we have a right level of exposure or a connect with the management also, right? So, we are sitting on the right side. Now, at the same time, it is very important that we are having a decent understanding about where we are consuming the data, right? A data engineer would be building all this analytical storage and processing in the data warehouse, right? Now, if you are started using this one, we being a technical person, that we should be having a sound understanding about what the data engineer has built and how I am supposed to use it. For that purpose, we are learning data warehousing and PostgreSQL. Now, the main purpose of PostgreSQL is to learn SQL, because when you say, if you say that I'm a data analyst, right? Honestly saying, it is very important that we should be having a strong knowledge on SQL or Python. Okay. And again, Python is a very coding language, so that is the reason I have picked up SQL. Okay. Now, in our 3 weeks course, data warehousing and PostgreSQL are like a minor subjects, and Power BI is our major subject. I hope in US this terminology you would be very close, right? In academics, we would be having minor and major subject kind of thing. So we would be covering data warehousing and PostgreSQL in the first week, right? Which would be contributing to 40%, and rest of the 60 to 65% we would be covering our main subject of Power BI. Okay. And the main purpose of learning PostgreSQL is that we want to have a solid understanding with the SQL, right? And this course is designed considering that whoever joining student, that they are completely new to IT, right? Or they have the basic knowledge about the Microsoft Office, right? Or some basic tools, and they want to switch their career. Okay, accordingly, the course curriculum also designed that we would be starting from the foundationals and the basics, and we reach out to the mid level. Okay, so that is, it is very important after the course that you are supposed to work on the certification and get it. It is very important. Okay, so my honest answer is that be SME, subject matter expert in Power BI, and have a decent understanding about the analytical or warehousing. That is good enough for starting our interviews, applying for the jobs, and we can easily crack the interviews also, right? Any questions or queries? The data to insight journey. So just to put these everything in a blocks, right? These are the different areas of expertise: data engineering, data factories, data science, data warehouse, databases, Power BI, industry solution, real-time intelligence, right? Now, this is a bigger picture, and we are not going to touch base all those things. It is very difficult, and we end up with the crossroads, right? So what is our target starting point is our Power BI. Our objective is that we should become experts in Power BI. Along with, we would be having a good understanding on the data warehousing and databases. Create operational SQL database seamless for transactional workloads. Scale up your insight by storing, analyzing data in secure SQL warehouse. Find insights, track progress, and make decisions fast using rich visualization. Okay. Taking a very amniotic, what will be your advice for me to put more focus on achieved in this course? So, first of all, consistency. Okay. Why the consistency means, suppose today if we have done our class, make sure before coming to the tomorrow's class that you have revised that class and you have done some hands-on. Okay, don't keep your work pending to the weekend or busy. Honestly saying, if you are allocating 1 hour, 1.5 hour for the class, samely you need to allocate minimum 45 minutes before coming to the next class to revise what has we learned on it, because my next class would be in continuation with the previous class. At most 30% topics that we have learned in the previous class would be repeated in the next class. Okay, so it's very important that you are having some homework also being done. Okay, that is one thing. And you should be having a Microsoft laptop. Okay, don't Apple laptop don't work because Power BI don't is not compatible on Apple version. And second thing, since you guys are completely new, I want to make sure that you don't have any confusion with the operating system or user interface. Whatever you are seeing in the video, as you can see, is the same in the laptop. So use the Microsoft Office laptop only. Okay. In terms of softwares for Postgres, SQL, and Power BI, I will be providing you detailed overview and explanation when we have our class so that you can easily install them on your laptop and work on it. Okay. Now, in terms of course, like with respect to data warehousing, we are going to cover the concepts. This data warehousing is, I think, introduced around 1980s or 90s. Okay. But still, this is intact, and every one of us, the underlying concept is the same thing that we use. If you use a data science, machine learning, blah, blah, blah. But like Newton's laws, right? Whatever the latest technology that we are implementing in the space, rocket science, everything, but that Newton's third law never ever changes. Same thing here. Data warehousing concept that you should really understand what it is. Then only you can able to clearly know, okay, why this particular database is created in a manner that it is having four tables. Each table is used to store customer information, account details, or branch details. So that kind of information. Okay. So within the Postgres, the main objective is that to give you exposure about the SQL language, structure query language, because SQL is like a universal language. Like if you know English, right, you can manage the things across the world in a majority of the countries. Same thing. If you have strong understanding with the SQL, right, even though the database that you are supposed to work would be different, but you can easily manage and make things ruling. That is the reason I have kept SQL also, right? So within the SQL, we would be learning DDL, DML, that means data definition language and data manipulation language. So the queries that are used to create the structures or objects, and also the queries used to uh, change the data, manipulate the data. Okay, queries and data. And then we would be seeing Power BI installation, Power Query, Power Pivot. These are the major topics that we are going to cover in the Power BI, right? A detailed further information is provided which all topics we are going to cover in each and every area, whether it's a data warehousing or it's a Postgres SQL. I'm going to share this particular deck with you, okay? And please provide your contact details so that I can share you this deck and you can go through them, okay? So in a nutshell, this is what we are going to cover. Uh, any doubts? And this particular course is about 3 weeks, that means 15 days. Okay, daily 1 hour, but it will be extended to 1 hour 15 minutes. So please be prepared that you need to allocate 1.5 hour daily during this time currently, and also a practice after the class. And all the class recordings are uploaded in the YouTube, and access would be provided to the registered students. Okay, first two classes are free. You can go through them and make yourself familiarize and come back to me if you have any queries or doubts. Make sure you have a right level of speed and quality in your internet connection so that the videos, YouTube recordings can be clearly seen. Okay. Now, by the time we ending this course, right, we are supposed to target Microsoft certified Power BI data analyst. Okay, and just to give you a glimpse, I just forgot. So our course is around 300 US dollars or 250 or 450, 300 accordingly as per the currency. Okay, so everything, and we are going to provide support in CV preparation, interview guidance, certification, right? And even after the batch also, you can join the subsequent batches also. Okay, you suppose in case you are not able to make current batch or if you have missed some classes, right? You can join the subsequent batches also without any additional costs. Okay, now coming to the certification. Microsoft Certified Power BI Data Analyst Associate. Okay, now this is very important that once we are coming to the end of the class, parallelly by the from third week, we need to slowly start practicing or going through these certification things, right? And prepare for ourselves. Now, if you see the level, it is intermediate. Even though our course, right, we are starting with fundamentals and going to intermediate level, but this certification we should be putting as one of the to-do list, right? Because this is where it tells, okay, yes, this person is certified Power BI data analyst. That means we can call him for the interviews. Okay. And role is data analyst. And it's a renewal every 12 months you need to renew, but don't worry, the renewal is free. It just checks whether the person is having a required level of knowledge. And yes, he is currently working on the Power BI, right? And the good thing is this Power BI preparing the exam is the second level of practice. First level is our classes. Second level is doing the homework after the class. And the third level is preparing for this exam. So we are targeting a three level of practice. Okay. So there are good number of topics are there. Now if you see here, this is a complete course. And our 15 days course will cover half, not half, at least 75% of all topics that are in this course, right? But what I recommend is, again, you do a revision of this course. Suppose if you open this particular path, you would be having, did I open the correct? Yeah, Discover Data Analytics. There are 6 units are there. It takes 36 minutes. So you just need to go on reading introduction, overview of data analytics, rules in data, tasks of data analyst, all those things. Okay, you just need to log into this one with your account and then just start using that one. Okay, better you use personal account so that it would be easy for you. There's a login issue, let it be fine. I will take it later. Okay, so in this way, we should be covering all these topics like a revising, I would say, right? And after that, we can have the lot of practice for the exam. So this exam is a 50 marks, 50 questions, okay? And the cost of this exam is around 165 US dollars. You can select your local currency also if you are not outside of the US, okay? And this is would be paid to the Microsoft itself. You can later on pay this one, I mean register for this one, and we have a separated team who can help you in registering this one so that if we have any discounted coupons we will apply those so that you can get some discount for the registration also. Okay, and there would be practice assessments, right? Why it is asking me schedule exam, take the practice assessment. Whenever I change the password again it will ask me. Okay, cool. See, we are going to have one of to 50 questions, okay, and the time window would be around 90 minutes like that, right? Now, you have begun the process of creating Power BI semantic model by connecting to data source based on multiple tables in SQL Server. You need to modify relationship between the table, which interface you should be using. So, model view. And don't go for the next. We normally check your answers. And the good thing is it will clearly provide a description about why that answer is right and what other options really for. Okay. So why I'm showing this particular assessment exam is because Power BI Microsoft is providing a really good amount of material or platforms where we can learn, thrive and complete it. It's just about we need to be dedicated, right? A consistent practice, not like, okay, on a weekend I will put 4 hours and I will complete everything. That is not going to really practically happen because if you're stuck due to whatever the things, then that 4 hours will be gone. Okay. And in terms of opportunities, that is very important, right? We all look, okay, what are the job opportunities for the Power BI, right? So let me search Power BI jobs in USA and let us go for the UK. There is a good number of jobs are there because in the current world, the main areas are like cyber security, data side. These are the two major things where really industry needs qualified people, skilled people are required, right? See, there are 3,500 jobs are showing, but again, if I further drill down to the entry level associate internship, I'm not going beyond that one because really, let us just filter out with really what we read. See, 1,000 jobs are there with the Power BI developer, right? And if I again, we need to scroll down which are the things. Suppose see Power BI developer, right? It is from Bangalore. I hope I searched it correctly. Power BI United States. Let me do a one more search. Okay. Seems it is taking my location and providing from India, even though searching is United States. Mhm. It is providing all the India related jobs. I think I should ask one of the student who is in the US to search this one. Mm, Earlier they used to get all the US jobs also, but why it is? Let me do one thing and prevent window. Yeah, Anytime experience level, intern, entry level, associate, then yeah. See, we got it, but again, they have of their business intelligence analyst Power BI, smart, innovative. See, yeah. Smart, innovative, hardworking, perfect. And another thing, whoever I mean want to work on Power BI, right? They should be having good analytical and business thinking, right? Because we need to think of logically. National Apartment Association employees salary 67 to 72K based on experience, Monday to Friday. These are common things, but if you go minimum of high school, strong SQL, Power BI, DAX, and Python, they are also asking. Excellent organizational time management, verbal, proficient in Microsoft Excel, building and maintaining Power BI datasets and models, dashboards with clear KPIs, gather requirements, right? Optimize SQLs for data extraction, transformation, validation. So these are all the topics that are going to cover in our topic, right? Business data, Power BI data analyst, Richmond VA. Okay, 60 to 65K. I think this is base package. See more. Requirement data warehousing, data modeling, dashboard, stakeholder review. All these things. Okay, let me scroll down to get more. House and see, develop and maintain Power BI dashboards and reports for lower, middle, and top management. Create efficient data modeling and DAX calculation performance. Integrate data and multiple SQLs. Power BI. All those things, right? So opportunities wise or openings wise, we have a really good um, number. Okay, 70,000 to 100K per year. Programmer continues. Okay, so there is a good number of job openings are there. It's all about they need a skilled persons who can really solve their problems. Okay, now as a part of our Power BI, we are also covering AIs, visuals, smart narratives, decomposition tree, all these things would be covered. Okay, so I'm just going to take a pause here. Hey all, can you confirm once again that you're able to see my laptop screen and I'm audible and clear? Thank you very much. Now, so hi all, thanks for your time till now. So now as we discussed it, right? So today we are going to cover our first topic called data warehousing concepts, right? Now, why it is very important in the data warehousing space, right? For this one, I'm going to take a simple diagram, right, which I use it for my explanation. Let me get the diagram in front of you. Just I'm copying this one and putting it into a new sheet, right? Now, what happen is in our organization, right? So daily day-to-day operations would be happen. Now, if we take a Walmart, right? Now, when you see or when you visit a Walmart, right, there would be a lot of activities would be happening, whether getting the goods, right, from the manufacturers or storing that in the warehouse and at the same time selling those things. All these activities would be captured in the databases or in operational systems because we see the day-to-day activities, what we call them as a operational things, right? If you have a college, whatever the day-to-day activities, we call it the day-to-day operations. If you have a manufacturing plant, right, we call it as operations. But mean whatever the day-to-day activities, business activities happens, we generally just term them as a operational things, right? Now, in the current world, all these operational things are captured in the respective systems. Either it can be a mainframes, it can be a databases, or there can be a front-end application, right, where we enter all the details, and when you click on submit button, the entire information would be pushed into the database, right? Now, at the same time, when a customer comes and says that, hey, this is my customer ID, right? I want to update so and so details, or I have a so and so inquiry, right? Then this operating system should be good enough to quickly retrieve that data, correct? So the operational systems would be working on smaller data, smaller chunks of data, right? Today you are purchasing something. That means there would be a 10 records. You have gone a grocery shop and you purchased 10 items. So there would be 10 records would be inserted into the database, right? At the same time, when you come back and want to do some return in those items, then we need to quickly retrieve that particular billing information, right? Now the organizations are grown globally, right? And we are having millions of data, right? So these operational systems that you are seeing on the left side, right? They mainly focus on serves the operational activities or day-to-day activities, right? Now, what happened over a period of time as this data has grown or growing, right? Some business or analytical people thought that, okay, why can't we use this data to do some analysis, to draw some insights on top of it? Knowing, okay, let us calculate how much total sales are happened in the last month or last quarter, right? Now just think in a simple layman terms. Suppose if you want, if you have a transaction for 1 year, right? And you want to see what is the total revenue that occurred every month, right? That means you need to sum up all the transactions for each month, correct? That means there is a lot of processing is needed. Lot of CPUs are required to do that mathematical processing, right? Now, initially that has worked fine. So there is an analytical team sitting close to the operations team or using the same operational system to do the analysis also, right? So these operational systems, which we call it as online transactional, is the spelling correct? Transactional OLTP process. We simply call OLTP, right? Which are meant for the online activities or day-to-day business activities are parallelly used for the analysis also, analytical process, right? Now, over a period of time, what happened is we started with the performance issues because the configuration or capacity is same, but along with the operational things, we are doing the analytical things, right? So then this resulted in performance issues. So then some two great scientists, right, Rolf Kimball and Enmal, what they proposed is, okay, let us do one thing at the end of the day or after the business hours, let us get a copy of whatever the changes has happened. Please note this importantly. Okay, it's not like entirely, but it changes whatever the changes happened in the operational tables or systems. Get that data into a staging layer and then store it in the warehouse. Okay. Now, while storing it in the warehouse, we are going to store the data, raw data as it is, so that we maintain the complete history of it. Suppose if you have a customer, right, his address is updated 3 times, right? In the operational systems, You may maintain the latest one. Okay, because whenever a customer comes and want to do some inquiry, or suppose if you want to send some kind of a debit card, credit card, or some kind of mortgage letter to him, you just need a latest address of him, correct? So the operational systems maintains the latest information, whereas whenever a change has happened, the information would be captured in the warehouse. Okay, so in the warehouse, we store the data in the raw form. That means it is going to have all the historical information. Say if you want to know a customer has moved from which particular area to which particular area, right? Or a customer's what are the things that he has purchased, or currently he is on which particular plan. He's a premium customer or he's a normal customer. All those things would be available in a simple plain raw data as it is from the source. Along with that one, since we want to do some analytics aggregations, we also store the summarized data. Okay. Now, it is very important that what kind of information we are keeping in the warehouse. Okay. When regulatories comes, right, they put a question to you. Okay, boss, what kind of customer information are you storing and how it is stored? Is it in a clear text where you can see customer name and address, phone number, or his health, everything, or some kind of a aggregated form where you won't be able to recognize the customer, but it will helps on some kind of analytical, right? So this metadata thing is the one where we keep what kind of information we are storing, right? Now, these warehouses are also a databases only, okay? They are not a kind of completely a different thing, like a simple database that which you are using in the operational system. Same database we use here also, okay? But the way we are storing here, if we store like a single record or latest information, here we would be storing all the historic information, and here we would be storing the summarized values. Okay. Now this particular data warehouse would be used for the analytical. So we term it as online analytical processing, right? OLAP. Since this is the place where we are storing data, we are calling it as a data warehouse, right? I hope you have seen the warehouses in the manufacturing and automobile industries, right? Where they keep their raw material or finished goods in an organized manner, right? Similarly, this particular warehouse where we are keeping our historical data or summarized data or metadata in an organized way, that is the reason we call it as a warehouse, data warehouse. Okay. Now from the data warehouse, we can take again a subset of the records. Suppose I build a warehouse for my organization, Walmart. Okay. Now within the Walmart, we would be having different business lines or departments, purchase department, sales department, right? Now sales department may not required about the manufacturing details, how much production is done, all those things, but they may require what kind of sales are happening geography wise, region wise, right? What products are being sold well, all these things. So we just create a copy, or it's a logical copy. Okay, there is a difference between a physical copy and logical copy. When we go deep into the SQL, we would be learning those things. Okay. So these data marts are exactly same as data warehouses, but they are the subset of data warehouse. Okay. In a nutshell, suppose at organization level, I build a warehouse and a data mart would be at the department level, purchasing level, sales and inventory. On top of it, the users, analytical users, Power BI users, Tableau users, right? Or all those things could be come and they will try to visualize the things. Okay, so the all this journey has come, right, to distribute the load on single system, right, and rearrange them in a orderly manner, right? Now, when it comes to the article, let me get you the article. Let me show you. Because see, after the class, I am going to share you the knowledge articles, right? These are the one, those are best picked from the available. Let me get the article for data warehousing that I'm going to share you over the mail. Class 1. Yeah. And for data warehousing, I got something very best with the AWS side, so I'm just using that one. Data warehousing is a central repository of information that can be analyzed to make more informed decisions. Data flows into data warehousing from transactional system, relational, and other sources. So if you see this particular diagram, data would be flown from the transactional or operational systems, from flat files, everything. Okay. Wherever there is a huge data requirement, then normally people will go for database. Okay. And this image is the this icon is the representation of the database. Suppose, let me get the shapes. Shapes. Okay. Just for your understanding, okay. This one, this represents a database. So in architecture diagrams, flow diagrams, if you want to represent a database, we use this particular shape as a database. And if I just compare this with our day-to-day life, right? If you consider our house, right? You can assume a database is like a house, right? Now within our house, right, we partition the space, right, with the different rooms like living room, bedroom, kitchen, because each room has its own purpose. And whenever you want to sleep, it should be like cozy, dark, and should not be disturbing. And living room should be wide with the TV and everything, kitchen room. Similarly, in the database also, right? Once we have the database created, we further create some tables, right? Each table has its own significance. One table would be storing customer details, another table would be storing account details, another table would be storing all the branch related information details like that. So each room, its own specific, similarly tables. Okay. And within a database engine, we can have multiple databases. Like in a street, we have multiple houses. Okay. And within the database is a organized one. A database is a place where we store data in a structured manner. Why? Because we first define the table structure and then we start inserting data into it. Okay. Business analysts, data engineers, data decision makers access data through BI tools, a Power BI, Tableau, etc. etc. Data and analytics have become indispensable to business to stay competitive. That is the reason, along with Power BI, we should be learning more about SQL. Okay, so I'm not going to read all this theoretical, but I will be highlighting some important points. Okay, if you see here, what are the benefits of using data warehouse? Informed decision making, consolidated data from many sources. So just correlate. I'm going to share this image also. Consolidated data from many sources. So you have the consolidated data from many sources. Historical data analysis. So you can have the raw data, all the history, so that whenever you got a new requirement, say business comes and asks, okay, I want to analyze a particular product sales for a period of time, then we can refer to the raw data and pull the summarized one and put it in the summarized database. Quality, consistency, and accuracy. These are very important things because if there is any compromise with the quality, then the results would be coming incorrectly, which means we are giving a wrong information to the business. Okay, so now when we say we are a Power BI data analyst, that we should be having a solid and the understanding about what my data and how to check the quality of data, all these things, and we are going to learn in our Power BI. Okay, so just to show you a glimpse, if I go within the Power BI transform data, we have some powerful tools in the Power BI. Now, if I select the sales data and go to the view, if you see we have a data preview here, just unchecking all those things. So it tells how many white spaces are there, what is the column quality, how many valid records are there, how many error records are there, how many empty records are there, right? Column distribution. So you can just simply select and it will give. We have 6 distinct records are there, unique, 25 distinct records are there. So this is about column quality, column profile. This is another interesting thing. They tells how many times each and every item is repeated. Yes, you need to select that one. A quick glimpse about how our data is. And normally this column profile happens on 1,000 rows. We can just change the settings to the entire data set also. A quick insights to understand whatever the data that I am getting from the warehouse is good enough to create my reports. Okay. Separation of analytical processing from the transactional database, which improves performance of both the systems. Right? This is one of the important thing, right? Similarly, we talk about data warehouse, databases, and lake houses. So these are like extension on how we can store the data. Okay, if a database, we can be used to store data in a transactional and in the analytical. Now, if you are storing the data for the analytical part, then we call it as a data warehouse, and majority of the data would be structured. Now, over a period of time, we got the requirement of storing the files also. Okay. Now, if you say insert shapes files, right? Now, some systems are providing capability to store the files also. Oh, that we call as a lake house. Now we don't. If you see, if you just do the comparison, right? A warehouse keeps the things in an organized way, so that we call it a data warehouse. Now, when you take a lake where you would be having abundant water, along with the water, you would be having other things also, animals, fishes, or some minerals, and etc. like that. Just not about the tables. If you want to store something in form of files, then we go with the lake house, right? If I take another shape, just take lake house, no fail. Okay. Now, a lake house consists of databases, files, right? Structured, semi-structured. Okay. Similarly, we can keep the things in the cloud, AWS cloud, Hadoop, GPS, Google Cloud, all those things, where you can store any kind of data, not about files, some online tweets, all those things, right? So I just have some comparison one. Just let me show you that one. Here it is. Now, if you see, we have different forms of data. I mean, if you term it at a high level, a structured data and a semi-structured and unstructured. Now, the systems or technology that we are going to use or can be used for the structured data is like databases and data warehouses. And what are the objects like tables? Similarly, we have semi-structured data like JSON, CSV files, tables, etc. etc. And those can be stored in the lakehouse. Now, when you say lakehouse, the example for lakehouse is like Hadoop systems and all those things. Now, unstructured data. So, unstructured data means anything, right? Let me get these two here. Cut. Let me put it here. Ha. Now, when it takes to the unstructured data, like videos, image, tweets, charts, files, tables, everything comes. Now, what is the technology we can use? The cloud. Either it can be AWS, it can be a Google, Microsoft Azure, whatever it thinks. Okay, that's are the things. Now, I hope you have got a clear understanding about the data warehousing OLTP and OLAP, right? Now, we have two great scientists, WH Inman and Rolf Kimball, right? They are like how Newton has proposed the Newton laws. Inman and Kimball has proposed two theories for the data warehousing. Okay, now let me show you a nice diagram that depicts what they have explained. Now, what Kimball has proposed is, if you see this one, right? Till now we are discussing on this one. Now, I hope you got some basic understanding about this flow, right? Now, within an organization, we would be having different operational systems, right? Where we would be having a system that manages by HR team, right? A system that would be managed by the sales team to capture all the sales and everything, a tally system like that. Now, there would be different systems, all those data is going to feed into central. Now, what Kimball has suggested is create smaller data marts. If you have a sales department where you are capturing all the sales data, create a data mart. That means a data warehouse for that particular department. Okay. Similarly, sit with the manufacturing department or production department, understand their department and build the data warehouse for them, right? And then integrate with the central data warehouse. Now, what is the benefit? That on top of the central data warehouse, the reporting and everything can be done. Now, what is the benefit of Kimball is that it will be iterative, right? We sit with one department and we build for it and we deliver that one. So we can also, end users can also see the results and they can also provide feedback if there is any gaps or improvement is required. Correct? So this is what Kimball has proposed. Now on the other lines, right? What Inmon has proposed is, no, don't create a data marts initially. Get all the systems together and build a warehouse at enterprise level. That means at the organization level. Okay. Get everyone from each and every department who are required to analyze, design, build the things, right? Once the data warehousing is built at the organization level, then give a logical copies in the form of data marts to each and every department so that they can create their own reportings on top of it. This is what Inmon proposed, right? Now, on seeing these simple diagrams, which one you feel that is the best, or which one you would be suggesting? Say, if you have a small business running, you are running a small business. What is your suggestion? Okay. Okay, Inmon, for Inmon to be get a one thing built at the same time, right? So both these approaches are successful, right? That is the reason we are learning both of them instead of ignoring one, right? Now, how it is based on the client requirements and how much client can invest on it. Now, let us see a comparative table between these two things that will give a clear picture for us. Introduced by respective scientist names. Approach, it is as a bottom-up approach for implementation. So, as we said that Kimball, they are going to start working with each and every department, right? So from the bottom, we are going to the enterprise level, to the top level. And Inmon is a top-down approach. So we are going to build everything at enterprise level and further we will drill down to the bottom. It focuses on individual business areas. Obviously, so I'm going to sit with the sales department and I'm going to build their one. Or suppose if you have a separate business lines for electronic equipment, I can sit with them and I can build their data warehouse and give it to them, right? It focus on enterprise wide. So at the organization level, it is efficient and takes less time. It is complex and consumes a lot of time, right? Because when we are building at organization level, obviously we need to know all those relations between each and every department, how they are interrelated, how the money, cash, or people will flow, right, between the departments, all those things. It has iterative steps and cost effective. Obviously, initial cost is used and development cost is low, right? This is one of the kind of a mixed one. Like initial cost is used, but when you go, development cost would be reduced because we don't need to rebuild the things multiple times. Once the design is finalized, that means we would be avoiding a lot of redundant things. It does not need such a skill, but a generic team will do the job. Yes, a sales department or who has knowledge about completely sales domain, he can build this one. Correct? It needs specialized skills to make it work. Here maintenance is difficult. So this is the negative point for the Kimball approach. The maintenance is difficult because each and every department, right, they are going to create their own data mart. So which means a sales department would be creating a data mart which would be having the employee table, and a manufacturing department they would also be creating a employee table, right? And there may be chances that the team would be that means at by end of the day that we will be ending up with multiple similar kind of tables, an employee table or salaries table or HR related thing, all those things. So the Kimball approach is bit difficult because there would be lot of hops. Similarly, for Inmon maintenance easy because we are building the things centrally, right? So in future, if someone want to use any particular data set or table, we can simply say, okay, boss, there it is already available. Don't create a new one. You can use it. Hmm? Now, data model. This is the terminology that we all should be well aware. Okay. And I want your attention here, couple of at least 10 minutes. Okay. Now, the Inmon approach is denormalized, whereas, sorry, my bad. The Kimball approach is denormalized, whereas Inmon approach is normalized. Now, just I have a simple question. Have you heard about this word denormalized and normalized? Anyone? Okay, fine. And from today, once you have gone through this one, right, you are not going to forget this one, right? Because it is one of the key and important topic for a data analyst. This tells why your data is segregated into multiple tables. Okay. For this one, I'm just already I have a pre-filled tables are there. Okay. And I'm using this one to give you an explanation. And whenever you are going to create any visualization, you may have the requirement to pull the data from multiple tables. And why it is that you are going to know as a part of this particular topic explanation, right? Now let us say you have a sales table. Say you go to the shop and you purchase there, and your respective details would be entered, right? Nowadays, what happen whenever you go to any shop or anything, right? They will first ask, hey, can you give your mobile number? Can you give your email ID? They capture all the details, address, and everything, correct? Now, if you are storing all the information in a single table related to that particular transaction, that the product name, customer address, more about product details and how much we purchased. All these things are storing in a single table, then we term it as a denormalized tables. Okay. And these are helpful in operational systems. Why? Because whenever you come and say, hey, this is my transaction ID, and you are supposed to get the results very faster. Correct? And how it can be achieved if your of all the details are kept in a single table, right? Say all your items are kept in a single room, then it is easy for you to pick everything very quickly, right? But that room may not be in an organized way, and sometimes there is a problem also. Now, what is the problem? Now, like if you take a Harish, he would be regularly visiting that store and he would be purchasing. That means for every time he purchases, when you are storing his complete details, then that means you are having data redundancy. Okay. The more the data you store, that means more disk space you need to purchase. That means the cost to the company increases. And is it really giving any value for operational system? This is good. But when you are on the analytical system where you are storing the history data, right? That means we are exponentially storing the duplicate values. Correct? Now, this Kimball and Inborn, what they suggested is, okay, let us normalize the things. What it mean by is, say, if I have a customer, I'm going to capture his details in one shot in one table. If I have the customer profile, if I have the product information, I'm going to capture complete details about the product in this product table, right? Now, whenever a new customer comes and asks for a purchase, instead of storing the complete details of that product or customer, I'm going to store their reference number that is stored in their respective table, right? So in this way, what is happening? Instead of storing a complete name, I'm just reducing with simple unique identification or a number. So the data storage has exponentially reduced in the normalized form, right? Storing of data into multiple tables in a logical way is called a normalization. What it is going to give us the benefit? The reduce the data redundancy exponentially, right? Here, instead of storing a lengthy text value of 20 or 50 characters, I'm going to store a unique address, right? Now, we call these supporting tables where we are storing a detailed information about the customer or product. We call these as a dimension tables, right? And the table that is used to store the transactions, observations, or call is called as a fact table, right? Facts. What are the facts? How much transactions happen? What is the observations? All those things we are going to store in the fact table. Now, this fact table would be having some dimensions. Those are called dimension tables. Okay. Storing the data in multiple tables in the fact and dimension, we call it as normalization. Okay. Now, if I show this relationship in a pictorial form, let me open that article. And again, this article is from our Microsoft Power BI. This article targets Power BI desktop data modelers. It describes star schema design and its relevance in developing Power BI schematic model. Okay, I will show first diagram so that you can easily quickly. Here it is. Right now, if you just correlate this particular diagram with our Excel sheet, I have a sales table which is storing all the transactions and their reference IDs sitting at the center. We call it as a fact table. And supporting tables, the dimension tables, those are referred, are stored surrounded. A products table, product information, sales territory, where the sale is happened, employee, who has initiated this transaction, a sales associate sitting there, and the date. So since this relation looks like a star, we call it as a star schema. Okay, is it clear about normalization and denormalization? Right? To understand some stars can describe this article, it is important to know two terms: normalize. Normalization is the term used to describe data that's stored in a way that reduces repetitiveness. So now here it is. So in a normalized table, we are going to store the product key, only product key. Now, whenever you want more information about this product, we will refer to the product table. But in denormalized, we are going to store full details about this product key. So that means data would be redundant. Okay. In this term, the way that reduce repetitious of data. Okay. Now this would be like so. If a fact table is referring to a dimension table for a customer ID 1 or 10, here in the dimension table, you should be having a unique record for that customer. Okay. So that is the reason we have this relationship, many to one. In database world, star means many or all. Okay. So in the dimension table, you would be having unique record, and this particular unique record can have multiple entries in the fact table. Okay. Say a single customer can visit a store and do multiple purchases. So that means his customer ID in the fact table would be repeated multiple times. But a fact table, if I want to refer the customer in the customer table, then it should be only single record uniquely identifying him. Okay. Now, since it looks like star, we have the star schema. Similarly, now if you take this customer address, the name, address, now when it comes to the city, within a city, if I am having 100 customers, think of it, then the city name, state name, again they would be repeating, correct? Duplicating. So how can I reduce? Maybe I can create another city dimension table and I can store the unique value of the city. So there is a multi-level relation. Fact table referring the address dimension, customer address dimension table again referring to the city dimension table. If we have this multi-level, then we call it as a snowflake. I hope you all know how the snowflake looks like, right? So if I show you a simple diagram, here it is. If our fact table referring to a dimension and this dimension table further referring to another dimension, then we call it as a snowflake. If it is just one level, it's a star schema. But if it is a multi-level, then it is a snowflake schema. Okay. Honestly saying, I'm going to share you all these links, and it is very important that you are going through this article and familiarize with this topic. Because when I say, hey, I am storing this particular customer details in this table and sales table in the you should be having an understanding, right? Why Hari is storing in different tables all the transaction related information instead of keeping them in a single table. If it is a single table, it's a denormalized. And all our warehouses follow the normalization approach. Okay. Power BI semantic model depends on Power Query to import or connect to data. Okay, when we see, we are going to see. That means you use Power Query to transform, prepare, source, which challenges the need of implementation. When you are presenting with the challenges we require, you first develop a data warehouse and extract transform function to periodically load the data warehouse. Your semantic model can then connect to the data warehouse. If you see this particular point, right? And that means you must Power Query to transform and prepare source data, which might be challenging when you have large data volumes or you need to implement advanced concepts like slowly changing dimensions. When you are presented within these challenges, we recommend you first develop a data warehouse and extract periodically data warehouse. So what it is saying is our Power BI has the capability to do the transformation, cleanup, and create a data model. But when it comes to the large data related projects, right? Obviously, in our organizations, your data would be large. So make sure you are having a data warehouse. And that would be built by our data engineers. And we are supposed to be having a strong understanding about it so that we can build right level of Power BI reports or dashboards on top of it. Okay. Dimensions. Dimension table describes business entities, things you model. Entities can include products, people, places, concepts, time itself. Fact table stores observation or events, can be sales orders, stock balance, exchange, temperatures, and many more. Okay. I'm just highlighting the key points, but honestly that you are supposed to go through all these things and make familiarize yourself. Okay. Fine. So we have covered almost all the topics. We have covered all the topics in a normal phase. Okay. So let me pause today's class here.